so we'll do chapters 4, 5, and 6, and then we'll kind of go from there on how we're talking about. Most of these chapters are going to be split up into two tests because there's a lot of information and it's new information. And so really have a test after the first section in this chapter, but that's a ways away. We're going to spend a lot of days on this kind of building that foundation of trigonometry. So again, really important in this moment of building that foundation, understanding trig as something we can be adding on to the whole semester throughout this. If you're absent, please get the notes. Make sure you don't get out of that. It's really important to have over the next couple of weeks. Okay. The first of them is what we're going to really talk about today, which is radians. Did you guys talk about radians in Algebra 2 at all? Some kids told me that Mr. Oswald showed some stuff, that it wasn't going to be all brand new. But radian is kind of a new word usually in precalculus because normally we talk about angles, we talk about degrees until you get to precalculus. And we're going to talk about just how converting degrees to radians today, and what is a radian is kind of the big concept. All right, so a radian is defined as a central angle of a circle has measure of 1 radian if it intercepts an arc with the same length as the radius. Is it really important that you memorize that definition? It's really not, but people always say, well, what is a radian? I don't understand. And it's just a way to measure angles, just like degrees are a way to measure angles. But a radian is defined as when this arc length is the same measure as the radius. So whether those happen to both be 1 or they happen to both be 700, if this is the same measure as this, then that represents 1 radian. What we tend to do is we want to talk about radians as in comparison to degrees, because degrees are what we're comfortable with, right? Like we know what a 90-degree angle is, and hopefully you know the other angles as well, but that's the idea of a radian. Why do we use radians instead of degrees? Because in higher math, radians are the only thing we ever use. We'll convert back and forth, and we'll do some stuff with degrees in here, but when we're talking about calculus and above calculus, radians are the only thing ever that we use, and so that's why it's important that we show them to you in precalculus. Okay? So, let's talk about what we know with the circle. Hopefully you know the circumference of a circle is 2 pi r. What does that mean, circumference? All the way around a circle, right? So if you measured a circle with whatever the radius happened to be, all the way around the circle measures 2 pi times the radius. Well, in precalculus we talk about this idea of a unit circle. So if the radius was 1, right, that would just be 2 pi times 1, which means that the circle has 2 pi radians for 1 whole revolution. How many degrees are in 1 whole revolution of a circle? 360. So one of the biggest things we're going to learn today is comparing radians to degrees. So if there are 2 pi radians in 1 whole circle, that's the same as saying 360 degrees. So we can use that to base some other ones. So if 1 whole revolution is 2 pi radians, what would half a revolution be in radians? Okay, let's do degrees first. What would halfway around a circle be in degrees? How many degrees would that be? 180, right? 180? 180 degrees. How did you get from 360 to 180? You took half of it, right? You divided by 2. So if there's 2 pi radians in 1 whole revolution, and I just want half of it, what's half of 2 pi? 1 pi. Our pi radians. Another side note, degrees. You put the degree symbol on it. Radians, you don't have to write the word radians after it, because if there's no degree symbol, then we know you're talking about radians. Alright, if you want to write radians today, you can. Get used to it. But just know, like on a test or on a quiz, if you wrote 180 without a degree symbol, then you're going to get it marked wrong if you mean degrees, because I'm going to read that as 180 degrees, because that's how we read math. A degree sign and say it's radians. So you don't have to put the word radians. So what if I went a quarter of the way around the circle, 1/4 of the circle? Let's think about a good old fraction day wrong. That's kind of a wash. But 1/4 of the way around the circle would be just this much, right? What's that in degrees? Degrees. Or you could say, how did you get that from 360? 1/4 of 360 is 90. So what would that be in radians? What would 1/4 of 2 pi be? 2. Or pi halves. Some people like to say 1/2 pi. I don't say 1/2 pi. I say pi. And then I just do another one in there. 1/6 of the way around, right? What would 1/6 of 360 be? 6 goes into 360. How many times? And what would 2 pi times 1/6 equal? That would just be pi of a radian. So because we have this ratio of having pi in the circumference of the circle, a lot of our radians have pi in them. They don't all have pi in them. Sometimes they're just ugly decimals. But a lot of our angles that we're used to have pi in them, so we'll kind of see that. I would say, like, at least even if I don't teach you trig this semester, I'm going to teach you to work with fractions, because most of our radians are in fraction form, and I'm going to teach you how to do that if you work with fractions, right? So that's kind of something. So this will be like common knowledge to you. Like, it'll just be able to know 90 degrees is pi half. Like, you'll just know it. So today the big thing is converting, and just like you convert anything, you can convert feet to mile, you can convert hours to second, right? Like, you just multiply by whatever big thing is equal, right? If I wanted to change feet to inches, I know that means 1/3 inches. I don't know, a mile, there's 25 feet. So, for degree to radian conversion, we could say, right? We could say we know in 360 degrees, there are 2 pi radians. But we could simplify that, right? We could make it smaller, and so that's why they use the smaller one of in 180 degrees, there are pi radians. Is it wrong if you use this conversion? No. You're just going to have to simplify it more. So that's why this is probably a better way to do it. Your book gives you this, and I think it's kind of silly, and we'll talk about it in a minute, but they talk about, like, what you're going to multiply by. Well, just like anything, like, to me, I always go back to my chemistry and, like, making my units match up. You write it however you want your units to cancel, but you want to write this down. If you're going from radians to degrees, then you want degrees on top, so you're going to multiply by 180 over pi. And if you're going the other way, if you start with degrees and you want to go with radians, then you need radians on top, right? Like, you need your unit on top. And again, I feel like that always goes back to my chemistry days. Then you'll just flip it around. So let's just practice a couple of these. Lots of time today. And if you questions. So convert from degrees to radians, and I wrote up here, like, if you didn't know which one to multiply by, you should be able to just think about, if I want the degrees to cancel out, I'm going to multiply by the one that has degrees on the bottom. Right? So if I want to change 120 degrees to radians, I'm going to multiply by pi over 180 degrees. Because just like feet would cancel out, or seconds would cancel out, our degree symbols will cancel out, and and then our answer is left in radians. And again, remember, you don't have to put the word radians on it, because there's going to be stuff. I do want you to simplify this and use calculator that you can use. There will be a no calculated part of this test. I won't put hard math on there. But like something like this, I think you could do without calculator. I think you can do without calculator. To me, I always just kind of simplify it like this, right? So 0s we cancel out. 12, 19, 6 goes into both of those, so that would just become 2, and that would become 3. And if you can write it nice, right? Like, don't take 2 times pi divided by 3. That's kind of ugly. I want you to leave pi in it. So if that means you want to take on your calculator 120 over 180 and simplify that fraction, and then just put the pi. So 120 degrees is the same as 2 pi, 2/3 pi. Okay? So do 20 degrees if you haven't already. Right, again, think about if I gave you something like this on a no calculator part of a quiz or a test. It's not that hard to simplify that, right? 2 over 18, that's just the greatest 2 pi. Questions about that? Just notice the next ones, we're just going the other way. Again, not too bad today, but kind of really important stuff today. What if I gave you radians and I wanted you to convert to degrees? To me, this is the easiest one, because if there's pi in this, and I know pi is going to go on the bottom, because I'm going to want those pi's to cancel out, if they can. Super great. So instead of multiplying, if we did on the last one, we're going to multiply by 180 degrees over pi. And again, if I can do it without a calculator, I can try. And if 6 goes into 180 30 times, so 30 times 7, 210 degrees. Really, really important that if you're giving me a degree answer, you put that degree symbol on it. Again, just because if you don't, then that's red at degree. So it's something that we have to make sure that you're doing as we're doing it. Same thing, different one, right? Yeah, that goes in there too. But I want you to know not all of them work out really nice. And so those are usually the ones that kind of throw people off. So I'm going to add an extra one here. I know they're going to throw off the numbers. So we call this 4A. Call this 4B. Your notes here. What if I said convert 3.7? People think, well, that's not a radian because it doesn't have pi in it. But it is a radian because there's no degree symbol after it. And a radian can be any number, so no degree symbol means it's a radian. And I'm still going to do the same thing. I'm going to multiply by 180 degrees divided by pi radians. But the pi's don't cancel out this time, which means decimal radian to start with, we're going to kind of have a decimal ugly degree to answer. So this is where I would say just type it all in your calculator. Take 3.7 times 180 and divide by pi. Because leaving pi in the bottom is just kind of ugly. It doesn't really help us anything. So just know that they don't all work out pretty. A lot of them do, but they don't all work out like that. $211.99 would be that. So I'm going to go 2. Not round up. I guess you could just round up to 9,000. Alright, so just be aware that it doesn't have to have pi in it to be a radian. A lot of times it does, but if there's no degrees involved, then okay, one other thing that I want to talk about today, as we're just kind of getting used to the notation here, is talking about degrees and being more specific with degrees. So we know in one revolution of a circle there's 360 degrees. So think about that for a minute and tell me how many degrees are in one 360th of a revolution. Just one, right? Because it would take 360 to do that. You can actually go smaller than degrees, right? You might think, well, we just use decimals. Well, in navigation, like stylists and people that drive boats, what are those people? I don't know. But in navigation, they want to be more specific to find exact location. And so they use these increments that break down degrees. So 1 degree is the same as 60 minutes. You just put like a little like apostrophe time kind of thing next to it. And then 1 minute breaks down to 60 seconds. And yes, they use the words minutes and seconds. It's like time. It's not time, no, it's units here. So if you've ever looked up latitude and longitude, it's written like this. Like they'll have things like 42 degrees, 17 minutes, and 6 seconds. If you're lost at sea, that's what they're going to use to find you. They're going to use that location. I saw something the other day that you could order, you could type in your favorite place, whatever it is, a city, and you can get the coordinates on a bracelet, because everyone's going to know what that means, right? But they were written like this. And so if you're not going into navigation, or you're not ever lost at sea or on a mountain, you probably don't use degrees, minutes, seconds, but they are still used, and they were used a lot more when people, drove all around. You don't drive on the sea. I don't know. Sailed. That's a good word. I think in the military they use coordinates like this. Like you hear, like on movies they do at least. When you hear them talking about locations to like drop bombs and stuff, rockets. I don't know the things. So I'm going to show you how to do this, and then I'm going to show you how your calculator takes all the work out of it for you and does it for you. Okay? So if we were going to do it old school way, we're going to take the decimal part and change it into minutes and or seconds if need be. The first one isn't that bad if you just think about it. But I'm going to take the whole degree part, like 27 degrees, stay separate. And then I'm just going to convert the degrees to the next unit smaller. So I'm going to say 0.5 degrees, and I would multiply by how many minutes are in 1 degree. 60, right? That's my conversion. So just like we did with the degrees and radians, I would say, well, 1 degree would go on the bottom, and I would multiply by 60 minutes, because then my degrees cancel out. And if in 1 degree there's 60 minutes, just think about what things should be here. How many minutes should be in half a degree? 30, which is what we get here. So we would write this as 27 degrees and 30 minutes. I don't have to go to seconds because there's no decimal left. If you got a decimal left, then you take and convert that to the next one. Just like if we were computing like 7.621 years, and then we converted it to months and then days and then hours and then seconds. You just keep doing it until you can't calculate it anymore, or you go to the last one. So let's do this one, and then I'll show you the calculator. Because this one isn't as nice, right? So 125.17 degrees. I take the whole degree part, I'm going to do up here beside here. I'm going to take 0.17 degrees, and I'm just going to multiply by 60. And if I do that, I get 10.2 minutes. So over there we got 30 minutes, so we were done. On this one, I'm going to say 10 minutes, take the whole part out, and now I'm going to convert this decimal, so 0.2 of a minute, and I'm going to convert that to seconds. And again, I'm just going to use the conversion that in 1 minute there are 60 seconds, which is just 2 of those little marks. So I'm going to multiply again by 60, because that would cancel out my minute. Every calculator is different. The hardest part about this is if you don't have a calculator like mine, we have to find the right button. But on my calculator, okay, so on my calculator, right below delete, there's a lovely little button that has a symbol for degrees, minutes, and seconds. If you have a different calculator, you might look for a button that says D in X. I don't have my calculator for it. So if you wanted to do like number 6, you're going to type in what it says, 125.17. You don't need to put the degree symbol. Just type in 125.17. And then on my calculator, you're going to hit that button, that's the degree minute second button, and you're going to arrow all the way over until you see DMS, which stands for degree minute. So on mine, I'm going to use the arrow and go all the way over off the screen, I hit enter twice, and it changes it exactly to 125 degrees. So one more delete, and arrow all the way over. If you want to go the other way, let's look at the next slide really quick, and then I'll help people. If you already have it in degrees, minutes, seconds, and you want to go back to the decimal, we can do the conversions again by hand, and I'll do that in a second. But you also can just, on my calculators, you can just type it in using the symbols under that button. So I can type in 315, and I go to that button, and I hit the degree symbol. And then I type in 48, and I go to that button, and I hit the minute symbol. And then I go to that button, and I hit the second symbol. And if you hit enter, it should just change that back to the You should bite, not talk about it, because I'm actually here. You guys want to go figure that out? So if you want to do it by hand, you could take 315 plus 48 minutes times, in 1 degree, there are 60 seconds, right? So you're going to divide by that each time. That'd be a little trickier on this changing seconds back to degrees if you're doing it by hand, because you have to change seconds to degrees. You have to do it twice, right? So you have to take 3 seconds times 1 minute in 60 seconds times 1 degree in 60 minutes. And if you work all that and add it up, you should get the same thing. Again, a lot less work if you use a calculator. But if you didn't have a calculator that did it, or you just forgot how to do it on the calculator, and you know the conversions, it always works. Um, but if you forget how to do it with your calculator during a test, I'm not going to show you how to do it. And again, notice it just says to the nearest hundredth, and so this goes on a lot of decimals. The nearest hundredth, you're just going to get 315.8.00. Degrees, minutes, seconds kind of shows up all the time. Like just when we think we don't need anymore, they'll throw a question and they write it like that, and you just tell them. So that's why I suggest know that your calculator is or you can just use your calculator in degrees, minutes, seconds. Or you can change it to decimal and then change it to radian. But just kind of know what it's There's a lot of time left. You took plenty of time to get started work. If you complete it, if you have a different calculator, I'll come around and see if I can find the button on it. Because I don't always know. So day one, you're just doing 2 through 24 even. A lot of converting. Again, a lot of time left, so you should be able to. Oh wait, not a lot of time left because it's prime time day, right? But decent time, right? So, as much as I can.